We're going to continue today talking about function tables. If you want to follow along in the textbook, I'm going to be on page 581. Let's do a quick review of some vocab. This is a function table, which is a way to organize all of our work. We've got a function rule, and this is also considered a function, which has one input paired with one output. So if you remember yesterday, the information was given on the input column, x. We had to apply the function rule and then get the answer or the output, the y. Well, today we're going to do it backwards. We're given the answer or we're given the output, and now we've got to think backwards to figure out what we started with. It's very handy that we have this work column in the middle. I like to use that to write out the equation. So that's not going to change. For each of our problems, the function rule is staying exactly the same. What does change is the output. Okay, so now I have to think backwards. 3 times what equals 6? And if you remember our unit on equations, you can actually divide, do the inverse or undo. So x here would be 2. And then I can check it. 3 times 2 equals 6, so I'm good. 3 times what equals 15? Or 15 divided by 3, x equals 5. And 3 times what equals 21? 3 times 7 equals 21. Okay, so you're thinking backwards or undoing what you see. Let's go down and do a practice problem. Now, these two are a little bit more challenging. This is a one-step expression or equation because there's only one operation. These would be considered 2 steps because you've got a multiply and a subtract or a multiply and an add. So these are a little bit more challenging. I'm going to write my expression and include the output as the other half of the equation. The expression doesn't change. The rule is 2x minus 1 for each one. We're just changing the answer. Now, you can do some guess and check and think of some numbers and put them in here and see what they are. There's another thing that you can do, though, is to undo this part first. Okay, so if you remember our balance scale, and we would take things from both sides, undo this subtraction. If I add 1 to both sides, this becomes 2x plus 2. Let me write it over here so you can see what I'm doing instead of having to keep it in memory. All right, so if we think about our equation, our balance scale, I'm going to undo this part first. Remember, opposite will cancel out. I'm left with 2x equals 2. Well, now 2 times what equals 2? X equals 1. Let's check it just to be sure. 2 times 1 is 2. 2 minus 1 is 1. So we're good. All right, let's undo with this one. 2x minus 1 equals 3. So I'll add 1, undo, do the opposite. I get 2x equals 4. And then 2 times what equals 4? So let's check. 2 times 2 is 4. 4 minus 1 is 3. And our last one, I'll add 1. 2x equals 6. Divide by 2 as I scrunch down into the picture there. X equals 3. 2 times 3 is 6. 6 minus 1 is 5. This is a more challenging one. It will pop up in some of the practice problems today, but if one of these was to show up on the quiz, it would be considered a bonus question because 6th grade is not responsible for equations with 2 steps. All right, I'm going to do this one real quick with you just to show you so you have some more experience with these 2-step equations. So we're going to do the 3x plus 2 all the way down. That function rule will not change in this problem. And then I'll make it equal the output for each individual line. So I now have created 3 unique equations. All right, so I can subtract the 2. I get 3x equals 15, which means x equals 5. 3 times 5 is 15. 15 plus 2 is 17. Take this 2 away, I get 3x equals 18. 3 times 6 equals 18. 18 plus 2 is 20. Take the 2 away here, we get 27. 3 times 9 is 27, plus 2 equals the 29.